Hello, this is Chemistry Lesson 8.03, where we're going to go over the categories of reactions. Now, this is a very high school type lesson. When you get to college, or if you take chemistry in college, you won't talk about these categories. You'll talk about reactions in terms of something called oxidation and reduction, which we will discuss, but it helps us to break down our categories into reactions. And if you remember, our cations are going to be the letters A and B, and our anions are going to be the letters X and Y. And these are when they're in compounds. So here we're talking about in compounds. But when we have a letter, so we would have AX and BY. But when we have a letter by itself, that represents an element. So if I have just A or X, these are all going to be an element. Do that. And we're going to have 5 categories of reactions. And so what I want to do is I want to show you. So let's go with category 1. I'm going to have you guys, I'm going to ask you category. I'm going to take element A plus element X. All right. Take a second and think about this, or pause the video if you want to. What are you going to form if you have a reaction where you have 2 elements? You have on the left side, these are my reactants, A plus X. What could I possibly form? Did you say AX? So I want an element plus an element, and I formed this ionic compound. Element, element, this is going to be an ionic compound. We call these reactions synthesis reactions because we're combining 2 elements to make a compound. Synthesis, I'm a little blurry. I'm going to see if I can focus. I don't think it made much of a difference. Category 2 is the reverse of this. What if I have an ionic compound, AX, and that undergoes a reaction? What do you think? Did you say we're going to break it down into its components, A plus X? So here I start with an ionic compound. I'm going to break this down into elements. We call this decomposition. This is a decomposition reaction because it decomposes. Decompose means to break down. Now, we're going to really oversimplify. We're only going to do decomposition reactions where we see this. There are a lot of varied decomposition reactions where you start with 1 ionic compound. You can break it down into 2 different ionic compounds. We're going to ignore those. And for the sake of simplicity, we're just going to go with breaking down a compound into its elemental components. Okay. Category 3. We're going to take AX plus B, or we're going to take AX plus Y. Well, wait a minute. What, why the difference? Well, remember, this is a metal and this is a non-metal. So you're going to take an ionic compound and you're going to combine it. So let's look at this first one. Just look at this top one. Take this ionic compound and combine it with a metal. What are you going to get? What's your prediction? Pause the video if you need more time. All right, did you say Bx plus A? Remember, cations are always metals. So if you react this with another a cation, these are going to be metals. These are going to be nonmetals. There'll be a displacement between the cations. But what if you react this with a nonmetal? What are you going to get? Did you say AY plus B? Or sorry, plus X? Why? Because you're going to get a changing of cation or anions. The nonmetal will replace the nonmetal. We call this single displacement. We're going to go through each of these categories in great detail, but I just want to kind of look at them all. And I want you to see where you can kind of predict already what's going to happen. So in this case, I had an ionic compound. I'm just going to put IC plus an element. Ionic compound plus an element. All right, category 4. I'm going to take AX plus BY What am I going to get? Pause if you need more time. Did you say AY plus BX? So what happens is the anions swap. We call this double displacement. It should note the other word that you can use is replacement. So they're synonyms. In some books, it says double replacement, and in some books, it says double displacement. All right, category 4 or 5. Is completely different because here we're usually dealing with covalent compounds. Everything up to this point has been ionic. But we take, in this case, a covalent hydrocarbon. Actually, it should be CH. So we have a covalent hydrocarbon. What is hydrocarbon? It means it has carbon and it has hydrogen. And we're going to combine that with oxygen. The category name here is combustion. So we're talking about basically burning something. Now we can have other things besides hydrocarbons that we can combust. We're pretty much talking about hydrocarbons. Anytime you burn anything, whether it's gas, whether it's firewood, whether it's propane, whether it's natural gas, you get two products. Even when you burn this in your own body, what do you get when you burn glucose in your body in order to make ATP? Those of you who are really good in biology, remember you get carbon dioxide and water. In this case, we really don't have to worry about getting our formulas correct because it's always going to be whatever hydrocarbon we start with plus oxygen gives us carbon dioxide and water. But all of these reactions come down. So One of the things we haven't said, we've said a chemical reaction is two or reactants, one or more reactants changing into a new product. So we've got something on this side and it's different on the product side. Well, we've been away from our orbital chemistry for a while. So let's talk about what's actually going on. What causes chemicals to react? We have protons, neutrons, and electrons. What particle do we say is responsible for element behavior? It's electrons. So the other thing we could say about a chemical reaction, we could say it's the result of changes in electrons. It all comes down to gaining and losing electrons. So here we're talking about gaining and losing. We're gaining and losing electrons. And we use two terms. We use oxidation and reduction. Now, right away, if I'm talking about gaining and losing electrons, you would think that if I am reduced, I'm losing electrons. The definitions are a little bit confusing for oxidation and reduction. And to help you remember, we're going to use a term. We're going to use oil rig. Oil rig, like out in the ocean that pumps the oil out. And if you use this mnemonic for oil rig, it stands for oxidize is lose or loss. Say lose. Reduce is gain. So oxidation is losing electrons or giving up electrons. Remember, E negative is electrons. Reduction is actually gaining electrons. We'll go through in a lot of detail when we get to the reaction categories where the oxidation and reduction takes place. But it all comes back to those electrons and those orbitals. And when they rearrange, they do it in such a way that they get to that lower energy state. And that's what causes chemical reactions to happen. So there has to be a payoff there. And the payoff is we get better electron arrangement after the reaction than we did before. The other thing, and I want to just add this here, we're operating as if all of the reactions we're writing will take place. There's a whole slice of chemistry where you have to decide if a reaction would actually occur. We're skipping over that. Why? Because we're high school and we got to save some of the fun for college. So just because you see two things on paper, that doesn't mean that they're like, if you throw sodium chloride and sugar together, you know, they'll sit there as sodium chloride and sugar for almost forever. They don't interact with each other really. So. Okay, that's our introduction. We're going to start off with synthesis in the first reaction category video to come up next. All right, thanks.